Hello and welcome to topic 1.3, which is on angles. Angles is what happens when you take some segments and some rays and put them together. You get an angle. You know a little bit about angles from middle school. So here we go. Let's define what some angles are. An angle is formed by two rays. You take one ray, you take another ray, you've got an angle that have a common endpoint called the vertex. The rays are called the sides. So an angle is made up of a vertex and two sides. The sides are called sides of rays. An example in this picture of an angle, we could write angle. You have to name an angle with the vertex. So the vertex always has to be a part of it. So if I want to name this angle right here, the vertex is important. We're going to name that angle X, Y, Z, and you put a little angle symbol. That's what it looks like, X, Y, Z. I mean, technically, it looks more like this. There's the angle symbol, angle X, Y, Z. You could also name it angle ZYX. But what do you notice in both the ways I name this is that Y is the vertex. The vertex is always in the middle. Okay? So you cannot name this angle YXZ. That would be a different angle. So Y is the vertex, so Y has to be in the middle of how you name it. You could not name this angle Y because this angle here has Y as a vertex, this angle here has Y as a vertex. So you have to use three letters if there's a shared vertex, like this picture right here. So Y is the vertex, and then ray YX. I'm going to run out of room. Ray YX and ray YZ are the sides. Okay, so that is an angle. Angle measure. Angles are measured in degrees for this class. Other classes, they're different. There are 360 degrees in one complete rotation around a circle. Which is why a protractor, a protractor has 180 degrees because that's a half a circle, and then going the full way around the circle, you get 360 degrees. Why 360 degrees? It's an interesting question. And the answer is, there is no answer. We don't know why 360 degrees. The Babylonians came up with that, and we don't know why they chose 360. They could have chose 100. And in that case, if all the way around a circle is 100 degrees, then a right angle would then be 25 degrees. But choosing 360 degrees, that makes a right angle 90 degrees. All right. So we could measure an angle, and you have to put the protractor on there and then measure it out. We don't have to do this very much, but it's measuring about 50 degrees. We could say the measure of this angle is 50 degrees, like that. So the measure of angle XYZ is 50 degrees. Whenever you say measure, you just put a little M for measure. An acute angle, if the measure is between 0 and 90, so not equal to 90, but between 0 and 90, that's an acute angle. So angle XYZ, being that it's 50 degrees, is acute. That's an example of acute. A right angle is if the measure is equal to 90 degrees. Put a little degree symbol there. Are there any right angles in this picture? Hopefully you say no. So there's no examples of a right angle here. But when you do see a right angle, you'll see a little box like that. So if you see a right angle, it has to have a little box in the corner like that, or it's not a right angle. You cannot assume a right angle if it looks like a right angle. It has to have a little box to conclude it's a right angle. Obtuse is if the measure is between 90 and 180. So over here in this picture, this is an obtuse angle. How do we name that? We could say angle WYZ. Angle WYZ is obtuse. That's bigger than 90 degrees. It's more than a 90 degree angle. It's more than a right angle. A straight angle, if the measure of the angle is equal to 180, it's a weird one. It's basically just a straight line, and actually we do have a straight angle here, angle XYW. That's a straight angle right there. This is 180 degrees. Can you figure out what this angle has to be? If this is 180, 50, this has got to be 130. Because what's 50 plus 130? 180. So you got 180 there, you got 180 there, 360 total, all the way around. If you start here and work all the way around, that's 360 degrees. The interior of an angle is on the inside of an angle. It's hard to describe that, but it's just a point that's on the inside. So if I put a point like this, call it point T. Point T is on the interior of XYZ of this angle, and point T is on the exterior of the red angle. It's like the blue angle could eat it, or the red angle can't. Okay, so that's interior versus exterior, outside. Interior versus exterior of an angle. Alright, refer to the figure, name the vertex of angle 4. So over here, here's angle 4, and you can just be kind of lazy, it's nice. You just put a number, and this number, I can tell that this is angle 4 right here. And angle 4 has vertex B. Name the sides. I don't even need the picture for this. A side is of an angle at 2 rays. So we have ray BD, and we have ray DC. And you can see that right here. The sides of angle BDC. BD, that's this angle right here. That's BDC. D is in the vertex. We have this ray, and we have this ray. Ray DB and ray DC. Those are the sides of the angle. Next, write another name for ray DBC. You could just flip it. You could call it CBD. Just write it backwards, but make sure the B is in the middle. Or, let's see what, DBC. DBC is this angle right here. DBC. B is in the middle, so we could call it angle 3. You could also call it angle 3. Write another name for angle A. Here's A. It doesn't have a number, but we could just call it, because it's not shared, because vertex A is not shared, you could call it angle BAD. And that's implied that A is the vertex and A is the vertex. And then, why is D an inappropriate name for an angle? How many angles have vertex D? How many do you see? Do you see 3 angles with vertex D? Here's one. You got 1 angle. You got 2 angles. And then you also have 3 angles. This angle here is also an angle. So there's actually 3 angles with vertex D. So if I said angle D, how do you know which angle I'm talking about? But if I say angle A, we know we're talking about this angle right here. So if you got a shared vertex, you cannot use just 1 letter. You have to use 3 letters. So why is D an inappropriate name? Because D is a shared vertex. So it's okay to say angle A, it's not okay to say angle D. Example 2, and by the way, you should be pausing these videos and trying the examples on your own before you watch me do them. Write 4 names for an angle. So there's 4 names for this angle right here. We can call it angle X, Y, Z. Call it ZYX. We can call it angle Y because it's not a shared vertex. You could just use 1 letter. Notice that Y is the key here. And we could also call it angle 1 since there's a 1 there. In the diagram below, label and highlight angle Q. Oh, Q's a shared vertex. You can't. There's no such thing as angle Q. It could be this angle. It could be this angle, or it could be this angle. Alright, so there's no angle Q in this picture. Congruent angles, like congruent segments, they have the same measure. Okay, and you use the symbol like this. So if 2 angles were the same, let's say if this angle was the same as this angle, you would put a mark in there like that, and that would show me that this is the same as this. Or I'd put 2 marks in here, and that'd show me that this is the same as this. That's congruent angles. Hopefully you can see that. Angle bisector is anything that cuts an angle into 2 congruent angles. So for example, let's say I got an angle like this, and I put a ray in here like this, and then you see 2 marks like this. This is now an angle bisector. It cut this green angle into 2 equal angles. So like this might be 40 degrees. Let's make it more realistic. This might now be 60 degrees, this might be 60 degrees, and this entire angle was 120. So what's 120 divided into 2 equal parts? 60 and 60, which makes this an angle bisector. The angle addition postulate says if I take 2 angles and add them together, here's what it looks like. If R is on the interior PQS, so here's PQS, angle PQS, and if R is on the interior like that, then I can draw a ray like that, such that this angle plus this angle equals the entire angle. If I measure PQR, if I take this measurement and add it to this measurement, I get a measurement of, adding them both, I get a measurement of PQS. So 2 pieces make a whole angle together. Example 4. If the measure of MPN is 60 degrees, we can label that right there, and the measure of RPS is 70 degrees, and look at this, what's this box mean? This box means 90 degrees, so we have a 90 degree angle right here. Find the measure of each of the following and classify it. Well, let's fill it in before we even look over here. If this is 90 degrees right here, what does this angle have to be to add up with 70 to make 90? It's got to be 20. What's 20 plus 70? 90. And then if ever you see a straight line, you know you've got 180 degrees. So if this is 90, and this is also 90 over here. Has to be, because what's 90 plus 90? 180 degrees. So that makes this 30. Because what's 60 plus 30? 60 plus 30 is 90. Now add them up. What's 60 plus 30 plus 20 plus 70? 180 degrees. Half of a circle. Straight line. Find the measure and classify it. So measure of MPR. MPR, that's this angle right here. MPR, so that's 60 plus 30 plus 20, which is 110. And 110 degrees is obtuse. NPQ. NPQ, we found that out. That was 30. And 30 is acute. QPS, that's our 90 degree. QPS. That's 90 degree. That's a right angle. And SPM. That's SPM. That's just a straight line. That's our straight angle. And that's 180 degrees. And lastly, angle P. These all have P as a vertex. So that is inappropriate. Don't do that. That's amateur when you do that. Alright. Moving on to the back page. It says find the angle measure of COA, then classify the angle. So here's a little protractor. COA. That's this angle right here. That's this angle here. You could just count. These go up by 10, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. 110. You could also do some subtraction. You know that this angle here is 1, 2, 3, 4, 5. So that's 50. You know that this is 20. So now take 180 minus 50 minus 20. And that will give you 110. That'll give you 110 for this. There's lots of ways to use the protractor for that one. Example 6. Name the vertex of each angle. So for angle 5, that's that angle right there. There's a vertex M. For angle 3, that's that angle right there. That has a vertex P. Name the sides of each angle. Angle 6. Angle 6 is this ray and this ray. So angle 6 is ray NM. And also ray NO. Starts at N, goes through O. Starts at N, goes through M. Same thing with 2. You can do 2 on your own. Write another name for each angle. Angle QPR. So P is the vertex. QPR. QPR. Call it angle 3. How about angle 1? Name another name for angle 1. Could you call it angle P? No, because P is a shared vertex. You could call it angle OPM. That would work. OPM, where P is the vertex. OPM would work. Alright, a couple more examples. Find the angles for the variables. So we want angle BAD. And by the way, I hope you're pausing if I'm going too fast, rewinding if you need to. That's this. I kind of like to go like that. What angle is that? All you got to do is add 31 plus 24 to make 55. Okay, so the angle here, you just add these together to get this. Next question. It says if EFG is 130, so if this whole angle here, I like to label it like this, is 130, the entire thing, what does this have to be? So take 130 minus 86, which leaves you with 40, 44. Right? Did I do my adding? Yeah, 44. Because 86 plus 44